Make sure you have your name, date, class period in the top right-hand corner. The title of this set of notes is Properties of Logarithms. And the outcome is to use the properties of logarithms in order to expand and condense logarithmic expressions. Remember that a logarithm is just an exponent. So when we're talking about properties of logarithms, we're actually talking about the properties of exponents. So we're going to start with a quick refresher on the properties of exponents. When you are multiplying two powers that have the same exponent, all you're going to do is you're going to add the exponents. If you're doing the power of a power, you're going to multiply the exponents. If you have an exponent on the outside, you're going to send the exponent into every factor inside the parentheses. If you have a negative exponent, it really sends your power down to the denominator. If you're going to be dividing two exponents, you're really going to subtract the powers. And then the last one is actually the same as power of a product. You're just sending your exponent into the numerator and the denominator. Okay. You don't need to know everything on here. The key ones to remember are the first one, the second one, power of power, and then the quotient. All right, so now let's talk about properties of logarithms. So the first, don't worry about all of this text here, just write properties of logarithms. All right, so we have log base b of 1 equals 0. Why is this true? If you do your LOGARWRL, you get b to the 0 power equals. You can use your calculator to check, choose any number for b. b to the 0 power, 2 to the 0 power, 3 to the 0 power, 4 to the 0 power. It will always equal 1. So if you have log base b of any number 1, it's going to equal 0 no matter what the base is. Second property. If you have log base b of b, it will always equal 1. So if your base and your number here match, it equals 1. Why is that true? Well, let's do the LOGARWRL. We're going to start at this base b. We're going to swirl around to the 1 and come back. So that says b to the first power. What's anything to the first power? Itself, b. That's why that points right back to a b. The third property, very similar to the second one. Log base b of b to the x equals x. So what this is really saying is if you have log base b and the b match, the answer is that exponent. Again, why is that true? Let's do our LOGARWRL. Start at the base b, come around to the x, and swirl back. That's saying that b to the x equals, oh, well, look at that. It points right back to b to the x. Fourth property, very similar to the third property. If you have a base b and you put a logarithm in the exponent and it says log base b, so this b and this b match, those are inverses of each other, so they cancel out and you're left with just x. Let me erase that so you can actually see it. And again, we could do our LOGARWRL to confirm this. Start here. Start with our base b, so that's saying log base b, and it whirls around to x equals itself, log base b of x. All right, the fifth property. It starts off with log base b of m times n. Back to those exponent rules that we just reviewed. I'm going to flip back. If I am going to be multiplying two exponents, I actually add the exponent pieces. So if I have two things being multiplied, I'm actually going to add them. So notice that when you have a logarithm followed by two things being multiplied, you're going to separate it so that they each get their own logarithm, and it becomes addition. Because when you are multiplying exponents, you add the powers. So that one's called the product rule. The log of a product is the sum of the logs. And I do want you to write that entire text down. The log of a product is the sum of the logs. The log of the product is the sum of the two logs. All right, we also have our quotient rule. All right, think back to your exponent rules. I'm going to flip back. My quotient rule says that if I'm going to divide two exponents, I subtract the exponent piece. So if I'm going to divide two exponents, I end up subtracting them. This is your quotient rule. The log of a quotient is the difference of logs. So notice that multiplication simplifies to addition. Division simplifies to subtraction. The last property is your power rule. So I have a log raised to some power. Remember, a logarithm is an exponent. So I have an exponent raised to some power. So it's really a power of a power. So if we flip back, we see that power of a power, that's this one here, oh, the second one, says that when you take an exponent raised to another exponent, you just multiply the exponents together. So this stuff here is an exponent, and the p is an exponent. When you have an exponent on an exponent, you just multiply the exponents together. So we're going to multiply p by the logarithm or the other exponent, because the logarithm is an exponent. So this is your power rule. The logarithm of a number raised to an exponent is the exponent times the log of a number. So if you have an exponent, it's going to turn into multiplication. I want to point to the word times. All right, here's the way that I remember this. I'm going to talk about my order of operations. Actually, let me scroll down so I have a little bit more room on my paper. So if I talk about my order of operations, I'm going to write this twice. If I am multiplying, it is going to turn into addition. If I'm dividing, it's going to turn into subtraction. If I'm doing exponent, it's going to turn into multiplication. Notice that everything is dropping down one level. Everything is dropping down one level. My exponent drops down, does not go across, it drops down. My multiplication does not go across to multiplication division, instead it drops down to addition. Likewise, my division drops down to subtraction. We do want to talk about our common and our natural logs since those occur so frequently. So remember, our common log is base 10. So if I have the log of 1, remember that the log, no matter what the base is, the log of 1 is always 0. The log of 10, remember that there's a base here of 10 that you don't have to write in. When the base and that number match, the answer is 1, no matter what they are. If I have log of 10 to the x power, remember there's a base 10 here, this piece cancels out, and I'm left with just an x, so the answer is x. And then the last one is, if I have 10 to the power log of x, remember that there's a 10 here, it's not written in, these cancel out, and I'm left with just x as my answer. The same rules apply for natural logarithms with base e. So the natural log of 1 is 0. Doesn't matter what the base is, the log base anything of 1 is 0. The natural log of e is 1 because the base of that natural log is e. The natural log of e to the x is x, and e to the natural log of x is also x. All right, so the change of base formula is the last thing we need to learn, and it's the one that helps us to use our calculator. Needed to use your calculator. All right, there's a lot of text here. It doesn't matter. All you need to focus in on is this right here and this right here. So it's saying if you have log base b of m, there are two things you can do in your calculator. You can either do log m divided by log b using the common log, or you can do natural log m divided by natural log b. So, quick example of this. Let's do the log base 5 of 25. And we already know the answer. What's the exponent if the base is 5 and the answer is 25? The exponent is 2. But let's say we didn't know the answer. We want to get it out of our calculator. Okay, the calculator does not have a base 5. It only has the common log and the natural log. So you can use the common log by rewriting this as log 25 divided by log 5. Base goes in the bottom. If you type this in your calculator, it will give you 2. You also could have used the natural log formula. It's the exact same formula, just using the ln button instead of the log button. So the natural log of 25 divided by the natural log of the base in the bottom, 5. Again, your calculator will give you 2. So either of those formulas will work for you. And that's how you calculate a logarithm using your calculator, especially if it's one that you don't know. All right, so this is it for our notes. Go ahead and draw your line for your summary and bring your notes into class.